Okay, let's start. I hope everyone can hear me. Today we will talk about K-map. So previously we introduced the miniterm, midterm, and max term. These two terms are so-called canonical form. Canonical form is a pretty standard way to express, convert a truth table like this to a Boolean algebra. Meanwhile, it can also, if your Boolean algebra follow the canonical form, we can easily, convert the Boolean algebra back to the truth table. So it's a standard way or algorithm to enable the conversion between Boolean algebra and truth table. After we have the Boolean algebra, it's not the simplified one. We have a lot of terms, of course. Each term is corresponds to one row of the truth table. So in this lecture, we will talk about the K-map, which is an algorithm to help you to simplify those Boolean algebras, Boolean equations. So besides the laws we studied before, De Morgan law, for example, K-map is a pretty standard algorithm which can help the computer to automatically do the simplification for you. But here we just manually to do it. So again, it's a method of grouping together expression with common factors and therefore eliminating unwanted variables. Maybe in your canonical form, you have 4 variables, which is 2 to 4 rows in the truth table. After the simplification, your expression may only related to 1 variable. That's very normal. So the K-map can also be described as a spatial arrangement of a truth table. So you can see you have a truth table here. This is a 2 variable truth table. 2 variable indicate 2 to 2, which is a 4 rows here. And we can redraw the truth table like this. So in the horizontal line, we have the A variable, but the vertical line indicates the B variable. So we can write 0, 1, 0, 1 here to indicate what's the case if A is a 0, what's the case if B is a 0. So this column, this single box indicates when A is a 0, B is a 0. This guy indicates A is 1, B is a 0. And then you can copy the number here to its corresponding box. I'm sorry, this guy should be here. This guy should go here. This guy should go to here. So in this way, you can complete the K-map. So we can see that the truth table, 2 variable truth table are exactly the same as the not exactly same, but it's equivalent to the K-map here. For example, one row here like this is related to this box. Why? Because for this row, A is 1, B is 0. So for this box, A is 1, B is 0. So you can copy this one to here. After we have some 0 binary value for the f, we copy these values to the corresponding box here, we can have this K map. And then we need to group these boxes in some way. For example, here is one example. Z is equals to this equation. And for this equation, we have two terms here. The first, so which is a mini term. So mini term is corresponding to the row, which can generate a 1. And the mean term is the, the true if this is A here, then this mean term is corresponding to when A is 1. B bar, we have a B bar here, so this mean term is corresponds to the when B is 0. So this is A is 1, B is 0, so we will go to this box, because for this box, A is 1, B is 0. And this term is related to A is 1, B is 1, which is this box, this bottom box. And then we have this K map. The next step is to group these two terms. We can draw a circle here. Eventually, by using one large circle here, we can express this Z. So what's the value of this large circle? So for this large circle, A is 1. So we can see A is 1. For this large circle, A cannot be 0 because we have nothing here. And for this large circle, B can be 0 and B can be 1. So it's not related to B anymore. We can ignore B. So eventually this Z is equals to A. A is the value of this large circle. Any question? If no question, I will continue to explain this one. Again, at the beginning, you only have this expression. This expression give you, this equation will only give you 3 terms. All the terms are mean term. Mean term, when you do some analysis on the mean term, if this variable has a bar, then it's related to the 0 case. If this variable has no bar, it's just the true form of this variable, then this variable should be 1. So for the first case, A should be 0, B should be 0. So we write a 1 here. For the second term, A should be 1, B should be 0. A should be 1, B should be 0, which is this box. And for the last one, A is 0, B is 1. It's this box. So how to draw a large circle to cover these 3? We cannot draw a large circle to cover these 3. Each large circle can only cover 2 to n ones. What's 2 to n ones? 1 is 2 to n. 1 is 2 to 0. So we can draw a small circle here. So when you just, cover a single one by a circle, that's reasonable. That's a right thing to do. But also you need to draw the circle as large as possible to cover more ones. How about the 2? Yes, because 2 is a 2 to 1. 3, no, because 3 is not a 2 to n. 4, yes, 4 is a 2 to 2. Because we need to draw a circle as large as possible, we cannot only cover this single one. We have to cover 2 ones at least. So I draw a circle like this, and then draw a circle like this. Can I draw a circle in this way? No, you can only draw a vertical or a horizontal one. If here is one, I can draw a circle like this, but you can not draw a circle in the diagonal direction. So after I have these two circles, I need to calculate the value for each circle. So for this vertical one, A is 0. So because we are also try to write the midterm. If A is 0, I write A bar here. B can be 0 and B can be 1. Remember, we have this law before. B bar plus B, which is a 1, okay? So I can add 1 here, and this guy is actually this guy. So this so-called vertical circle is A bar. And I will calculate the value of the horizontal one. For this horizontal one, A can be 0 and A can be 1. So because this circle covers this one and this one, A can be 0, A can be 1. So we can ignore A. And the B can be only be 0. So I write B bar here, and then you have this one. So in this case, I finish the simplification by the K-map. You can so I will give you more details on the K-map. The K-map can only cover once. This is 0, so this is not right. It can only cover once. You cannot draw a circle in the horizontal one. It can be either horizontal or vertical. It cannot be in diagonal, in the diagonal direction. This is not right. This is wrong. So if you can draw a horizontal one and the vertical one. So if this is the K-map, you need to simplify what you can do. Because this is 0. Unlike this one, this is 1, this is 0. You cannot have this, this case. So if you have two ones here, what can you do? You just give them two circles. It cannot be simplified after you translate or calculate the value of each circle. It is still the same as your original Boolean expression. If you have any question, please interrupt me. Again, you can only cover 2 to n once. This is 2 to 1, okay? 2 once. Can you cover 3? No, the answer is no, because 3 is not 2 to n. So if I give you this K-map, how can you, simplify it? You need to use two circles. One, you can either draw something like this, or you can group these two and have this single one here. This is right because you have 4 ones here. This is not right because you have 5 here. You can only have a 2 to n. 4 is a reasonable number. You can draw something like this, or like this. This is the first one. This is the second one. Each group or each circle should be as large as possible. So for this one, you can draw a 2 large circle, but these are not right because you divided it into 3 groups, and the groups can be overlapped. You can see that these 2 groups are all actually overlapped. Each one must be in one group, in one circle. and the groups can be overlapped. This is not right because again, it's not large enough. And you can, the group can wrap around. For example, these two can be in the same group as these two. So the rightmost can be in the same group as the leftmost group. I'm sorry, the rightmost cells can be in the same group as the leftmost group, leftmost cells. And yes, please.
On the last slide, on the top one, why isn't those two overlapping? So on the top one with group 1 and group 2?
Yes, you can draw a group like this.
Oh, okay. Thank you.
And if you draw two groups like this, it's also right. But again, the overlap one may be better because each group should be as large as possible. Yes, you are right. And here, the rightmost cell can be in the same group as the leftmost cell. And the top cell, for example, if you have a 1 here, of course you can draw them, group them into one group, and you can also view them as this in this case. And we should have as few groups as possible. If you can use 2 groups to cover them all, you shouldn't use 3. Here, I would like to remind you one special case. I believe in most time, I even make the same mistake. Again, we have 3 variables in this K-map. We write AB here, C here. So for C, we have 0, we have 1. For AB, we have 0, 0, 0, 1. This is not 1, 0. This is 1, 1. Okay, this is the, one point you need to remember. Why I write 1, 1 here? Because for the neighboring column, I hope that only one variable changes. From this column to this column, B changed from 0 to 1. From this column to this, from 0, 1 column to 1, 1 column, only A changed from 0 to 1. B are the same. For these two columns, B is actually 1. B stay at 1. For this column and this column, A stays at 1, but B changed from from 1 to 0. So this is the reason why I write 1, 1 here instead of 1, 0. And you can see that you can view the K-map, in this way. So this is the, I label the box, this box as 2. So this is the 2. When you actually, put the K-map in this form, the 2 actually is connected to 0. This is the reason why you can actually have some group like this. You can group the rightmost cells in the same group as the leftmost cells. And again, this is 1, 1, not 1, 0. So I summarize all the rules here. No zeros allowed, no diagonals, only the power of 2 cells in each group. Each group should be as large as possible. Everyone should be, every single one should be in at least one group. Overlapping is allowed. Wrap around is allowed. You should as few group as possible. And these are the the possible way to draw the 3 variable K-map. You can have a group of 1, which is a mini term. You can have a group of 2 and a group of 4. You can even have a group of 8. So here is one example for you to do some exercise. This is 3 variable logic expression. We have A, B, and C. You can write the K-map like this. You can write A here. So this is 0, this is 1. You can also write BC here. This is 0, 0, 0, 1. This is 1, 1. And this is 1, 0. For the first, this term, A is, because we have an A bar here, A is 0. C is 1. For C is 1, we actually have a 2 box. This box and this box. So I write 2 1s here. And then I have ABC. For ABC, every variable is 1. So it's related to this one. And then I have a B and C bar. C bar indicates C is 0. So this column indicates C is 0. This column indicates C is 0. And B is 1. And this column indicates B is 1. So I have 2 1s here. And then I need to group them together. The easiest way is something like this. You group these 4 together, and then these 2. Because the overlap is allowed, so you can do this. And yeah, that's all. So this box indicates this term, A bar C term. And you can see that if you directly get this map, you cannot group them like this, because apparently you should have as large, the group should be as large as possible. You can group these 4 together. And if the Boolean expression are in the canonical form, you can directly fill this box. I have some, so I actually index this 3 variable K-map by the row, by the midterm index here. This is 0, 1, 2, 3, 4, 5, 6, 7. This is a 0, 1, 2, 3, 4, 5, 6. I'm sorry, 6, 7. And you can, because here for the midterm you have 7 here, you just have a 1 here, 5, 1 here, 3, 1 here, 2, 1 here, and then you have this. For this case, you can draw 2 groups here. Can you draw something like this? No, because you should have as few groups as possible. So the vertical one is useless. Can you draw something like this one, and this guy? Again, no, because you should have as few group as possible. So two group are the best case. For this one, you just fill one here, one here, one here, one here, and a 6 here. Apparently, you can do something like this, and then do something like this. So because you have one group here, what's the value of this group? Again, this group across the 4 cases of Z and Y. So this group is not related, shouldn't have Z and Y at all. But X is always 0, so it's X bar. And then for this one, X is for this vertical one, X can be 0, X can be 1. It shouldn't have any X at all. And the Y is 1. Y is 1, so I have Y here. And Z is 0, so I have a Z bar here. This is exactly the result. And here are 2 more access. You can try to do them. But compared to the previous one, this expression is not a canonical form. So in this case, you can easily, understand the difference between the so-called canonical form and the not canonical form. And then we have 2 variables. I draw A here, B, C, A0, A1, 0, 0, 0, 1. Again, this is 1, 1, not 1, 0. This is 1, 0. For the first term, A bar, B bar, C bar. So A, B, C should be 0. For this one, A bar, so A should be 0. B should be 1. So these 2 columns indicate B is 1. So A is 0, B is 1. Then I have 2 1s here. For the third one, A, B should be 1. A is 1. B is also 1. C has a bar here, so C is 0. So this is this term. A, and for the last one, A, C. A should be 1. C should be 1. And this column indicate C is 1. And these 2 columns indicate yes, this is. So eventually I have something like this. I can draw a large group here. For this one, I make this circle. For this one, I draw this circle. So eventually I have 3 terms. The largest one is this one. For this one, A can be 0, A can be 1, and C can be 1, C can be 0. So this is only a B. For this one, A is 0, so I have A bar. And B can be 1 and B can be 0, so I have no B. And the C can only be 0, so I have a C bar here. And the last one is this one, this guy. This guy, A is always 1. B can be 0, B can be 1, so I have no B here. But C has always 1, so I have AC here. So these are the answers. The different from the answer, I draw A here, but they group A, B here, draw C here. They are the same. You can try them yourself. Again, this is 4 variable case. For 4 variable, again, this is 1, 1. not 1, 0. This is also 1, 1. And then you can, label the corresponding mini term. This 4 variable is just like this shape, because these two columns are actually connected, and these rows are actually connected. And here are some rules for the 4 variables. For the 4 variable, they are the same as the 2 variable case and the 3 variable case. You should have as few as a group as possible. You should the group should be as large as possible. And each circle indicate a 4 midterm with 4 variables. 2 adjacent square represents a product of term of 3 variables. A rectangular of 4 variable indicate a product term of 2 variables. You can try these laws yourself. So here is one example how to simplify this canonical form. Remember, if something can be right in this, the sum of the midterm is canonical form. And you can, because you have a 0, 1, 2, 4 here, you can fill the 1 based on the canonical form. And then you can group them, these ones. I have this large circle. And these 4 are actually grouped together. Because they are connected, we can group them together. And these 2 can be grouped together. So eventually, I only have 3 groups. This is the first one, and this is the second one, and this is the last one. This is the final equation. So only 3 terms, because I have 3 groups. So eventually, I want to introduce a new so-called new value. So some variable can be in the don't care value. Don't care value means they can be 1 or 0, but I don't care. Because there may be a combination of input value which will never happen. If they do happen, the output is of no concern. The function value for such combination is a so-called don't care. They can be read by with this symbol. This don't care symbol can be 1 or 0. We can also utilize the don't care to simplify the K-map, because they can be treated as 1 or 0. So here is some example. If you know these don't care, you can write these symbols here. And then you can try to group them together. So I can have this group. Why? Because I can treat the don't care value as 1. And I can also have this one. This is also right, because I treat these 2 as 1. These 2 as 1. Do I need to care about this? No. Why? Because I can treat it as a 0. Can I draw these 4 together? No, you cannot have a group where you only have a don't care. These are not correct. Don't care has to be grouped with other variables. You cannot have with other values. You cannot have a group where you only have don't care. That's not correct. So if I consider them as all zeros here, it's very difficult to simplify this, K-map, because, basically these ones are separated from each other. But if you treat the sum of them as one, then you can have a very large circle here. But one single circle cannot only have don't care. That's not right. This is another example. Can I draw a circle like this? Yes, because you have don't care and you also have one. How about this? This is also correct. And by these two circles, you cover all ones. You can finish. Do you need to, mind these three don't cares? No. The answer is no, because you can treat them as zero. If I draw something like this and something like this is also correct. And these two solutions are both correct because both of them have a two large group and each group have 4 values, covers 4 boxes here. So which means that for the K-map, multiple answer can be right, can be correct. And equally correct, of course. Any question? Okay. So I will briefly introduce the syllabus. So in this lecture, we cover the K-map. For next week, I will introduce the adder. Adder which can do subtraction and addition. And then I will introduce deep learning. Because in this class, we need some application. We need to write a VHDL code to design hardware for some particular application. Of course, you can find your own application, but I will recommend deep learning because deep learnings are very popular or hot today. And after I introduce the deep learning, I hope you can design a hardware to do the network inference. I will introduce multiple algorithms, simplified algorithm for you to do the network inferences. As you know, the network inferences heavily depends on the multiply accumulation operation. That's a very naive baseline. Meanwhile, I will introduce the algorithm to do the inference by the addition and the shift operation. All XOR, pop counting, you count how many ones are there in a string, binary string. We can do the network inference by these Boolean logic operations. So that I hope some of you can pick up one algorithm to do the acceleration. And you can also, collaborate with other students so that you can form a group to do the project. We do not have exam. We only have a project. You need to do some presentation to propose what project you want to do, and then update the some results. Eventually, we will present the results of your project. Yeah, that's the plan for future several weeks. Any question? If no question, we can stop today. Thank you very much.
Thank you.